Hello and welcome to this podcast, Semiconductor Advancements in India, where we'll explore the advancements happening in semiconductor field in India. I'm Dr. Sriganesh Rao, a researcher under the Maitri program of DFAT Australia for developing a roadmap for Australia-India strategic collaboration on semiconductors. I have with me Mr. Navin Bishnoi, who is the Associate Vice President and the India Country Manager at Marvell India, where he leads all business and engineering operations across the region and represents Marvell in external engagements. Naveen has led custom ASIC design across networking, processors, cloud, automotive, and AI/ML domains. He has held senior positions at IBM, Freescale, Cadence, and Texas Instruments. He's a long-standing contributor to the India semiconductor ecosystem through his involvement in EDA standards and industry association. He has also contributed to national initiatives serving on skilling committees. He has been jury for startup programs and has been on the advisory committee of the India semiconductor R&D ecosystem. Naveen currently serves as the Vice Chairperson of the Executive Council at the India Electronics and Semiconductor Association. He is a recipient of various awards, including GCC Leader Award of the Year 2025 for Engineering Excellence and the Ecosystem Development, and many more. Welcome, Naveen. Welcome to this podcast.
Thank you, Dr. Sri Ganesh, and I'm excited to be here.
It's a pleasure to have you here. You had an illustrious career in the semiconductors. What excited you to choose a semiconductor field?
Yeah, good question to start with. Like many of us, when we started in late 90s, probably semiconductor and VLSI was not as well known as right now today, where everyone talks about it. So I would say that being an electronics graduate, I wanted to be in electronics, and I didn't realize that semiconductor is one of the niche subsegment of that. I ended up being employed by Texas Instruments right from college, and so VLSI and semiconductor happened to me by chance. But I would say is that within 6 months, I realized that semiconductors or VLSI was sitting at the intersection of what we call as physics, electrical engineering that I had studied, and the digital future that we are setting it up. And then that kind of set the so-called as interest as well as excitement and inspiration for me to continue on the semiconductor field. I was like so excited first time when I saw a chip saying such small chip can do so much more with the software on top of it. And then that's where I would say the love for semiconductor started, and it still continues for the last 3 decades.
That's wonderful. Uh, so could you also explain us your personal journey in electronics and the semiconductor domain? How has been your career going through in this field?
Sure, yeah. I would try to divide this into maybe 3 decades that probably I've been part of it. The first decade, I'll call it, was more an engineering foundation
Mhm.
development. What started with Texas Instruments, a small time at Cadence, and then a long time again with Freescale, which is where I got to see what it takes to build EDA tools, build the methodologies on top of it, and then use all of that to build chips across the domain of networking, consumer, automotive, and some of the custom silicon.
Mhm.
That put the foundation of engineering for me in the first decade. And then I launched the second decade to start doing what I called as a leadership development for me as well as for the organization that I served. Is that how do I connect different pieces together and start driving projects so that we can be the best projects from those market segments? For examples, in Freescale, we did a lot of automotive chips end to end right from here. Even before some of the functional safety and the ISO standards came into picture, we were building those, and we continue to do that. Back again in IBM and Global Foundries, we did custom silicon for these upcoming data center, cloud, and the carrier market to again drive a lot of custom silicon, advanced node complexity that we had to build a leadership for organizational as well as technological development. And then over the last, I would say, decade or less, I've been focused on saying now how I can contribute to the ecosystem building, right? I have done product development, I have scaled the teams, I have connected many of these. How do I take it outside to connect with academia, the government, the associations, the peer and partners, so that the ecosystem flourish and we can have India semiconductor ecosystem where we have I would say, a co-development or co-participation from the global companies, large Indian companies, the startups, academia, all of that. So that's the journey I am in middle of, and I'm excited about the opportunities ahead.
Yeah, it's a great journey. You've gone through the entire life cycle of semiconductors. That's wonderful to know. Now, in your present company, Marvell, um, uh, what is the focus area of Marvell in this field?
Yeah, Marvell is a fabulous chip design company. We are one of the top five fabulous companies from US. And in our primary focus, what we call is a data infrastructure semiconductor
Mhm.
solutions, primarily covering the market of data center, which includes AI as well, the cloud data center AI, the carrier, the enterprise, and then some part of the security infrastructure that goes in. This is driven by our mission statement that we build semiconductor solutions for data, where we process the data, move the data, store the data, and keep it secure. Right. So you'll see a lot of processor, networking, and storage and secure elements as part of our silicon chips that we do. And this goes into the end segments that I talked about. And hence we are I would say, most relevant company in the AI growth era that we are seeing. Specifically from India, Marvell has been in India for 20 years and then grown up from building small pieces of R&D across different domains, different products, different technologies into a huge conglomerate or the reflection of the headquarter to have every engineering, every technology, every development work replicated here, and as well as few of those technologies being completely done here end to end. So that's where Marvell and Marvell India fits in into the overall ecosystem.
Wow, that's nice. Uh, Semiconductors are the brain behind every system, and nowadays, whether it is a computer, mobile, any kind of home appliances, or in the telecom, or anything that we think of, it is based on semiconductors. What would be the role of the semiconductors in the country's economy and national security today?
Yeah, so I think the way to look at it, it started with the simple that semiconductor is let's call it the backbone of the whole digital economy that we are trying to build, right?
Right. Mhm.
Everything around us is getting digital at a very fast pace. And if you go underneath, the foundation is enabled by semiconductor, whether it is the AI, the telecom, the space, the defense, energy, healthcare, you name a place and it's digital, and hence a semiconductor being the backbone of it. So there are two angles to it. One angle is definitely saying how much of this is built here or import versus export, and you see that there's a large percentage which is more imported from outside and leveraged in these use cases, which puts it's a huge, I would say, import tax and the other things on the economy for us versus building from here. But the second part is also about if we go into some of these mission critical or the national importance topics, which is the defense, aerospace, space, and many of the other use cases, which is very relevant to India. The semiconductor becomes not just the backbone, but actually a strategic asset, right? It's
Yeah.
definitely commercial in nature, backbone, but it's more a strategic asset that we need to do. And hence, there is so-called as a need for some level of a control over these capabilities, right? The semiconductor capabilities. And that could drive what we call as a economic resilience, or as well as the national security to build those digital and the platforms for the mission critical segments.
Yeah, so it is very important for every country.
It
And
is.
for a country which has to enter newly into the semiconductor field, what do you think is more important and easy for a country to enter into this? Is it the fabless design or setting up of fabs?
Yeah, I wish the answer was one versus another, right? So you and I have seen it. It's not either or one, right? So
Okay.
Both are required. It could be one could be strategic or sequential against each other. The way to look at it, let's see, right? The design is about the IP creation, the product creation, the system understanding, and system creation. This
Mm,
enables the value creation, right? That you can create a value and as well as solve the problems that you see across both within India and for the globe. Whereas if you look at manufacturing, which is multiple factors, there is a fab, there is an OSAS, there are materials and machines and an EMS and many others is needed for supply chain resilience. And we need to see what is important from different regions' perspective to start to say is that which sequence we start, first create the resilience of supply chain versus IP creation or the vice versa. In India, if you see that we had the so-called, I would say, kickoff of design-led IP creation, product creation, and all of that for the last 4 decades, primarily driven by global companies and then by the Indian companies, the startups, and all of that. The missing layer was the supply chain resilience, and we fit that in and expanding the design as well as fab. But long-term success for most of these actually comes from the probably a coexistence and the co-evolution of design and manufacturing along with the ecosystem.
okay. In the last couple of years, we are hearing a lot of news about semiconductors in India. What is the significance of this? Why is so much of talk about semiconductors nowadays at the top level in India?
Yeah, so I think some of this was triggered probably by COVID, an outcome of COVID that when we had the supply chain challenges and then a lot of people started hearing saying your car cannot be delivered, you cannot have a new laptop or we don't have supply to give you the cell phone with this much memory and things like that because there were just the supply chain challenges that came up post COVID as part of the borders being closed and sealed. As we saw, then the geopolitical tensions, the war, and something else, the so-called a second level of supply chain resilience and other things also started becoming visible and critical to the nature and hence the acknowledgement of having a focus on semiconductor as a strategic asset, as a strength rather than a import dependency from others, evolved and became the talk of the town, right? So it primarily started from the global supply chain disruptions, and then we figured it out that this is foundation to all our aspirations. We talk about Viksit Bharat and hence the digital and economic reforms and ambitions. It is driven, which is foundation is semiconductor. And hence there is a lot of talk and focus about how do we move from a service economy, a talent provider to the world, to something called as a technology creation or a capability creation, value creation in that. So that's the talk. And then frankly speaking, I'm enjoying the talk because I missed that for the last 2.5 decades.
Okay. Yeah. So with this, Indian government had come out with the India Semiconductor Mission some time back to address this important field of semiconductors. So could you tell us more about this mission and the what kind of incentives they provide for companies to invest, I mean, to progress in this?
Yeah, so India Semiconductor Mission came into picture a few years back. Uh, I call it as a very strategic as well as structured long-term framework and vision for building the semiconductor ecosystem. And then good thing is that it is we have seen the 1.0 version of it and 2.0 version of it. The 1.0 was focused on what we call as how do we get the manufacturing supply chain and specifically first focus on fabs, logic fab, the compound, the display, the OSAT and ATMP, and some level of design incentives and then those part of that, right? The second one is going into the next level to look at the complete end-to-end supply chain, to also look at the other parts of the gases, chemicals, the materials and machines, and many others, including a focus on R&D in alignment with design and manufacturing growth as well. So I think the focus has been continuing to increase. It has ensured that there is an intent or a vision. There's a capital and incentives that is put together. There's a policies that has been done, and there has been ecosystem created with the hubs that the global and local companies can pick and choose and then grow from there. So in all aspects, if you look at it, it shows that there's a stability around policies and the intense visions, as well as some level of seriousness, which is very critical for investors. And then hence you see the growth and so much of energy and talks and an investment that's coming in through the Indian semiconductor mission, as well as building around that.
Okay. And now with the implementation of this mission, what are the current semiconductor status, what are the kind of fabs which are being set up or being set up, whether it is the fabs, the OSAT, the ATMPs, and the DLI. So if you could actually throw some light on the current status of this, that would be nice.
Sure. Yeah. So I think there is enough material to talk about the exact each project, their
Mhm.
focus area and the investment, and probably you can put that along with the summary of this talk. But if I look at from a top level, right, we focused on saying we need to get a fab. We wanted to have the logic fab. We also wanted to have the specialty fab, a compound, silicon carbide, and many others. And then
Mhm.
we do have a logic fab and a silicon carbide fab. Those are the two ones that project is approved and is under progress of implementation and construction and getting ready for us to start seeing chips coming out of that. Along with that, we also realized that the OSAT side of the world, which is where we say is that the assembly, packaging, and testing, a less capex, a slightly easier problem to solve, and then probably needed significantly because you have a wafer and then you dice it into many chips, and each one of them has to go through an assembly, packaging, and testing. And hence, there's a bigger business opportunity immediately available to get started. So those were the two, I would say, the starting focus, and we have 11 projects ongoing, couple of
Mhm.
them in the fab and rest of them in more in the OSAT and ATMP side of things. Along with that, we also launched the fabless startup support. We have seen more than 25 projects being reviewed and approved to be given support through that incentive so that they can accelerate their product development and then start doing their prototype and the first chip out and then taking it to the market. In general, good momentum and then good ecosystem partnerships. When the fab comes in, OSAT comes in, they have started partnering with, again, global and Indian companies to see is that sign an MOU and an intent so that, hey, when we get into this product line, this technology or something like that, I start leveraging these India supply chain through these fabs and OSATs, and then ensure that these partnerships grow to create the resilience of supply chain, but also leverage the technology development that's happening. Most importantly, we need to understand semiconductor is a patient game. It's an early days, even though people might say ISM has been there for 4 or 5 years. It's a much longer game. It is a decades-long game, so it's an early days. But directionally, we are moving rightly. So that's a very important thing.
Yeah, Navin, you mentioned about incentives like the design-linked incentives and so how are the incentive schemes like the design-linked incentives or the production-linked incentives, how have they helped the Indian semiconductor ecosystem?
Yeah, so let's look at the two which is most talked about, right? The DLI and PLI, and then there
PLI.
are few others as well, right? Specs and an ECMS and few others, right?
Mhm.
Look at DLI. It is supposed to enable what we call as let's call it unlock the innovation and entrepreneurship to create an IP or a product in the fabless design world. So whether it is a use case of a surveillance camera or an IoT use case or an edge, and probably some of them have started looking at power modules, automotive, and then maybe in data center as well, right? Whether it's the processor itself or the networking piece of it. So that's the one that DLI is supporting by ensuring that they have one capital and incentive support, but secondly, also have support through the government program so that they can access to some of the things which are very costly from a product development perspective. Access to IP, access to EDA tools, access to labs where you can do prototyping, you can do validation, you can do FPGA, you can do bring up and all of that. So those access is equally important along with a incentive which is given milestone based and all of that. So that's the DLI, which is unlocking innovation, entrepreneurship, and the IP/ product creation. Whereas if you go to PLI is primarily meant for reducing the risk for a large capital intensive investments, right? This is more on the manufacturing where there's very capex heavy. It takes time to get the factory ready, get the line started, and then be able to get into a business where you can start looking at profit or something. So you need some way to manage the risk or reduce the risk. So PLI supports that with a support from the central government and some of them from the state government as well. So together, if you combine both, creates product which can lead to design-led manufacturing, manufacturing supported by the risk reduction, and it just gives the confidence and probably what I call as a velocity to this growth that we wanted to see in India.
Okay. And has these schemes, of the ISM, have they helped the organization Marvell in any way?
I would say indirectly, yes, right?
Okay.
The schemes are primarily more for either manufacturing, in which case global companies are eligible for that, or the the product creation, which is more for the Indian startups. So Marvel directly may not be eligible this thing, but indirectly, I would say strongly yes, right? Take simple things like that. The scheme is also creating a program called C2S, through which couple of hundreds or more than that colleges have access to again all of these things, right? They have access to EDA tools, the IPs, test chip shuttles, some of the other things, and hence it has created a huge talent pool that a lot of us need for our product development for India and for global, right? So for sure, the ISM scheme has helped through talent pipeline. It has accelerated some of these academia collaboration because once you have these programs, the academia has access to this. So they can partner with us to not just do a talent creation, but also do some joint research or a proof of concept and prototype, and hence we can leverage that. The third one I look at it is like ecosystem maturity, right? When this all is getting created, there are a lot of EMS companies coming up. There are other support partners coming up. There are OSATs. So we have been looking at saying how can we leverage those ecosystem partners as we go through our end-to-end product development. And hence, I would say that, yes, indirectly, this is helping Marvel and every global companies that's operating in India.
Oh, okay. So the India Semiconductor mission is kind of unique to probably only India has this kind of a mission. If you see around the other countries, this thing. What are your thoughts on the success of this mission?
Yeah, I think a lot of people start measuring success by number of projects that's getting approved, and then probably it's a start, it's a metrics. I'm not debating that, but success is not truly the number of fabs or this thing, right? We need to remember fabs are capex intensive, not just in terms of dollars, but also about the resources that we use from the environment, right? Air, water, chemical gases, and many other things. The real success or metrics would be is that what's the depth of the capabilities that we have created, right? So how we are talking about moving from that service or a talent market or mindset into a value and capability and
Mhm.
innovation mindset. So is that the depth that we can see that there are products that's getting created by these startups and Indian companies and becoming global? Are we able to create billion-dollar and many billion-dollar valuated companies, product companies from here? Is the supply chain really resilient, or we get into these supply chain challenges about when we have geopolitical tensions and not able to procure something for our strategic missions and all of that, along with the talent, the IP, sustainability, and
Mhm.
and then the import metrics that we have been tracking and all of that, right? So there are multiple metrics to look at it, and as I said, it's a long game. The foundations are being led, and the success metrics are many of them, including what I spoke about, from capability to number of apps to the resilience of the supply chain.
Okay. Yeah, with the kind of encouragement which is given for semiconductors by the Indian government, as you actually, as you have been explaining, where do you see the India semiconductor industry going, probably 10 to 15 years from now?
Yeah, I think a
We're still
decade.
guessing.
Yeah, a decade is a good time to start so-called as forecasting, and I'm glad you are asking decade and not 2 to 3 years, right? I think decade will put us in the so-called as a competitive region or a hub for the semiconductor design and system innovation, along with others. We have been doing that, but probably for the global companies rather than from the combination of global and local companies. We will definitely have the manufacturing and packaging at scale by that time. I would say the packaging probably will be at the advanced packaging for sure. That technology is growing fast, and I'm seeing the roadmap from many of them putting advanced packaging as part of their roadmap and be able to support the complex chips or systems that's coming out, especially in this whole AI data center space as well. Manufacturing probably might still be a combination of more legacy or specialty, and maybe an aspiration to start from the advanced one for some of these because the capex for those is significantly higher, and there are only a few companies who can do that, right? But for sure, this will enable the what we call as the product development to have a very strong presence in telecom, automotive, AI, and then maybe custom silicon because India will have its own use cases to drive those custom semiconductor silicon for those use cases. So in a decade, I am very confident we will see the so-called as scaled fabs, advanced packaging, and many products at a global deployment across some of these key sectors.
For the semiconductor fabrication, the critical minerals are very important, and we hear a lot about the talk about the critical minerals worldwide right now. What is the role of the critical minerals in semiconductor fabrication?
Yeah, so we have started learning about the whole part of supply chain. Many of us didn't realize that something as simple as air, water, chemicals, gases, and minerals are also so critical. And as we get into whether we are building the wafer and whether it's a like a silicon wafer or something else, along with all the materials that's required during the manufacturing, we realize the importance of these specialized materials and minerals that's needed. It's very critical. There are quite a few elements from the periodic table is what gets used in there. Uh, India doesn't have all of them. It's not fully self-sufficient, and probably no country will have that, right?
Mhm.
This is where the strategic sourcing, procurement, partnership will be needed so that when we make the supply chain of manufacturing, we can source it from outside as well as we being able to source it to others where we have this thing. So it's critical. Not my area of expertise to go into each which one is the most critical versus others, but it's part of the supply chain, and there's a huge focus from the ISM on an ensuring that we have those partnerships.
Yeah, you've been part of the IESA, which is the most important association in electronics and semiconductor field in India. Can you tell us more about the role of IESA in advancing electronics and semiconductor capabilities in India?
Yes, so ISA stands for the Indian Electronics and Semiconductor Association. It got set up 20 years back, started as a India Semiconductor Association, and then got extended to add the electronics as well because they both go together. And then it has become the voice, or I would say the voice or the convener of the multiple bodies coming together: industry,
Mhm.
academia, government, and startup. So those are the four bodies we say is that, or the four stakeholders that have it. And the common voice or the common platform or the common convener for this is IESA. The key focus that ISA focus on is for sure the policy advocacy, saying what kind of policies needs to be considered, the incentives, the effectiveness of that, the gaps that we have in some program, and then all of that. So that becomes the big thing to work with our governments and other associations and in other regions and other associations to bring that together and then drive that forward for the country. But along with that, also look at saying how do we contribute to what we call as an ecosystem development. And in ecosystem development, how do we take the academia along to ensure that they have the right directions on workforce development, R&D creation, and then having a more hands-on experience so that the talent that's coming out is immediately useful for India, for the globe, and not just for design, but also for manufacturing. And third one is that ISA also acts as a global partnerships with the other region association so that we can bring in the so-called as the regional focus from one country or one region to another and ensure that we can leverage the ecosystem. Maybe we have very strong design ecosystem, whereas something else in the Southeast Asia is more stronger in manufacturing. And how do we partner and ensure that we can share with each other on ways to ensure both region grows using the expertise of others. So it's primarily a key player in policy advocacy, the ecosystem building, and the global partnerships. And I would say like it's finally the most important platform, ISA, that it bridge between the intent with the execution.
Oh, yeah, that's nice. And yeah, so both of us are from, based in Bangalore currently, and we see a lot of large companies and startups who are involved in the fabless design. What do you think of the Bangalore in a semiconductor ecosystem? What is it that is attracts so many global companies and startups to design chips here?
Yeah, yeah. You and I have seen this growth, right? What was called as a retirement capital or a capital for the public sector companies for India, whether it was defense or strategic, many other large electrical, heavy movers, and many other companies, who knew that this would become the so-called as the Silicon Valley of India, because 4 decades back, my first company came in and established their R&D center and then we have seen that then everybody has followed. And it's now not just the semicon, but actually all other functional is coming in. But specifically from a semiconductor, Bangalore became a head of, I would say, or epicenter of fabless design, uh, because probably we saw that in this part of the country, the education focus, the kind of institutes that we had, and hence both talent and R&D was available at a stretch, not just located to only Bangalore, but you go around Bangalore across within 500, 800 kilometers. Many of that was available. So that was the starting point. And then one followed other and then combine it with the, I would say, we can't miss about the Bangalore weather and then the so-called as the Cosmo culture that it lets you get in. It became the epicenter of fabless design in India. And hence you see today is that we have large multinationals, the startups, the academia, the R&D labs of all
Oh,
of that primarily being from Bangalore for many of these things. So it is a large scale that we have already built in here. And slowly we are moving from that large scale into a leadership and a value creation from Bangalore and then from many other similar pockets that are evolving in the country.
okay, that's nice. Um, what do you feel, about the geopolitics that is happening in the world and currently? Would that have any impact on on this strategy which is being followed in India right now? For example, the tariff or probably on the pack silica and things like that.
Yeah, so I think the background remains that the geopolitics has made semiconductors more strategic, right? That was the one which drove semiconductor to become very strategic and no more an optional topic of discussion there, right? Uh, Good thing about India is that I think our policy is very strong. There is an intent, there is an inclusion of every entity, so it's not just design or just fab or something like that. It is about everyone and then along with that, in general, the way India has been progressing, we have kind of emphasized, I would say, a trust. And then on that trust, we are trying to say is that, hey, India is an opportunity for diversification, right? Which is probably neutral in nature if you look at from many of the political angles. So it positions more India as a global partner rather than being a competitor or take away something, to diversify, to neutralize some things, and leverage the huge ecosystem, which is both competencies and the consumer that we have. So that's a good place to be a global partner in terms of the overall global challenges that we are seeing.
Yeah, so it's good to know that it's a positive impact for India, and it is,
It is.
initiated all the,
We will see
yeah.
some of those intermediate, I would say, situations and other things, and probably that's part of the evolving geopolitics and all of that. I still remain confident that we are moving more towards a global partner with all the actions and the policies
So
in
you
place.
say that global partnerships are important for India for the semiconductor ambitions, right?
Yeah.
And okay, any thoughts on collaborating with other countries? What kind of collaboration India can have with other countries for the semiconductor mission to be successful?
Yeah, so I think let's connect that, right? I told you that
Yeah.
global partnerships. And the reason I say is that we have to realize that no country, no region, no company can do semiconductor alone. It's a
Mm,
very global, interdependent value chain that exists,
mm,
right? The partnership starts from the technology, right, that gets created, whether in the manufacturing or in the design side of it, and then being able to cross the borders and then get the end product out that you and I can use as humans and be part of the better future for all of us. And hence, collaboration across countries is important. Uh, with Australia, I think the two opportunities that immediately come to my mind is that one, for sure, the critical minerals that Australia has. And then secondly is the whole research angle and focus that we have seen with the universities around there,
mhm.
focusing on the strategic research and all of that. And then if you cross combine it with India, which says I have the talent, I have the design ecosystem, and probably a system capability to have the systems that is useful for the global market, I think this gives us an opportunity to collaborate across the materials, this research, and then combine it with the design and supply chain resilience.
That's nice to hear. And so, Naveen, any final thoughts on how India should um, go forward in this area to uh, uh, for the ambition to be fulfilled?
Yeah, so India semiconductor journey, I would say, is not just about chips. It is about the capability, it is about the confidence, and it's about the collaboration. And then if we build the ecosystem right, the technology will follow.
Mhm.
So that's the excitement and that's the inspiration that we have. And I'm very confident with what I'm seeing around. And then to be part of this, to be able to contribute to it and then get benefited from it as a company, as an individual, and as a citizen.
You also been the jury for the startup competition and all that. What is your advice for startups to enter into this semiconductor field?
A couple of, I would say, what I'm looking at it is that so there is a huge, I would say, complexity or the variety of opportunities that exists. We can build something simple to solve what happens in the villages, in the rural areas, or in the large consumer mass that we have. But we also have the opportunity to bring in something about how do we contribute to the AI and data center, which is probably the most complex and most costly, but it has to be built based on the constraints that India provides, and hence that can be deployed if proven in India, can be deployed anywhere. Whether it is the power management problem, whether it is so-called as the connectivity challenges, and all of that. So my advice have been is that ensure that look at the problem statement or the gaps that you are finding, and ensure that those problem statement gaps can be scaled to the global rather than just be at India. And then secondly is to focus on saying how do you create an IPN product that adds value rather than a me too which can be copied, and then you can have 10, 15, 100 other companies that could come in. So that's my two advice that I'm trying to do. I'm sure there will exist many others, but those have been my focus.
Yeah, that's nice. And well, thank you once again, for spending your time, for this podcast. It's been wonderful to have you here. I'd
My
like to
pleasure,
thank you.
Dr. Sriganesh. I'm excited to see what you are doing, not just in India, being part of the startup and many other things, but
Yeah,
also partnering with global regions and companies to bring in opportunities and either as Marvell or ISA and part of the semiconductor ecosystem. I look forward how some of these leads us to a bigger vision and a bigger outcome.
sure, sure. Okay, thank you, Navin. Thank you.
Thank you.